All right. Good morning. Welcome back. Good to see you all. We have another lesson here, but before another lesson, another joke. Okay, what did the guy who got paid to sleep say? He said, "This is my dream job." Okay, let's have a lesson. All right. Now today we're looking at solving more inequalities, in particular the more difficult types. So last time we looked at, I guess, linear, some linear ones. But this time now we're looking at solving, I guess, more difficult ones. For example, quadratics um, and absolute values, and like basically when we have a per numeral at the bottom or variable at the bottom. So let's take a look at this one here. The best way for me to show you is to go through examples. Now I'm going to show you graphically and algebraically because it's important that we understand how both work. So the first one here, we've got x squared, take away 4x, take away 12 is greater than or equal to 0. If I'm solving it graphically, first I need to know how to sketch it. So if I want to know how to sketch it, I'm going to want to factorize it. And so here, if I was to factorize, what I would end up getting is I'd get, okay, it's going to be x. And I can see this is going to be minus 6x plus 2. Okay, because minus 6 and plus 2 add to give me negative 4, but multiply to give me negative 12. And I'm going to have this greater than or equal to 0. So to solve this graphically, I'm going to mock up a quick little graph here. Doesn't have to be perfect. And I'm going to sketch it. Now I know that it's going to cut at 6 and cut at negative 2 because I'm looking at my y or my x-intercepts because of my factorization. So from this one here, I can see that x equals 6 is going to be my x-intercept. And then hopefully you guys can hear me. Sorry if it's a little bit quiet. And then x would equal to negative 2 for this one. So that's there. And I know my parabola is going to look like somewhat this. Okay. Now it's saying, when is this graph going to be greater than or equal to 0? So you can kind of see that it's been broken down into like almost 3 sections, right? I guess on this side here, we're greater than or equal to 0. In this middle section here, we're actually less than or equal to 0. And then on the other side here, we are greater than or equal to 0. So if I'm talking about when are my x values going to be greater than or equal to, well, I can see that it's going to be when x is greater than or equal to 6, or x is less than or equal to negative 2, because that's when my graph is positive. That's when my graph is above, greater than or equal to 0, if you can kind of see. And again, they'll often ask you to sketch your solution. So I'm going to write there's a 6, there's negative 2, and then we can equal. So I'm going to color in those circles, and that there would be my solution and its sketch of the solution. Okay, now algebraically, I'd get it to the same point here. I'll just go x minus 6, x plus 2, greater than or equal to 0. Now, again, I kind of know that from here, I make a little side note that x equals to 6, x equals to negative 2. I'll sketch that out on a number line, 6, negative 2. Now, what I'll do is I'll test x equal to 0, and I'll test it all the way back into here. So if I was to test it, it would go, okay, 0 minus 6, 0 plus 2 should be greater than or equal to 0. So now I've got minus 6 times 2, which is minus 12. And is minus 12 greater than or equal to 0? The answer is no. Okay, so that means if that's the case, I'm not inside, I'm not in between the 2 and the 6. I'm actually going to be on the outer kind of sections here. So I'm going to pick this one. Okay, I'm going to be pointing outwards, 6 and outwards. So that's how we would solve it algebraically. Sometimes it's easier, depends on which one you favor. Okay, so you always got to kind of find the points of interest, I like to call it. Points of interest. And then from there, you test a section. Okay, now let's take a look at an example where we talk about algebraic values, or sorry, absolute values, algebraic values. So first things first, if we want to solve graphically, first things first is I would sketch it. Okay, so there's that. Now to sketch this, I'm going to have x plus 2. So I know that x plus 2 is kind of going to look like this. And so I know it's going to keep going until it hits the bottom here. And then it's going to bounce all the way back up. Yep. So that's going to be -2. That's going to be 2. That's going to be 2. Now, when is this value, when is this graph going to be less than or equal to 2? So the way that I see it is, okay, the other one is we've got y equals x plus 2, and then we also want to kind of graph y equals 2. So y equals 2 is a horizontal line. So I'm going to draw this horizontal line across. And all it's saying here is when is this graph of y equals x plus 2 less than or equal to 2? So I can kind of see that that's only going to exist. It's only less in this section here, that little green section, right? Because anything to the right or to the left of that green section, it's actually the graph is greater than 2, not less than. So here, all I need to do is, okay, I can see that this value here is 0, and I can see that this value here should be -4. So if I wanted to solve this, I'd just say, okay, for this to be true, my x values have to be in between -4 and 0. So I'd write that out. It'll be in between -4 and 0. And that's it. That's my solution. Again, you can sketch it on a number line. 0, -4. We're in between and we're including. So we do the full circles and connect them up. Algebraically, could be, this one could take a little bit more. So we've got the absolute value of x plus 2 less than or equal to 2. Absolute value just means that we're going to have a positive outcome. And let's deal with the positive. So if we have positive x plus 2 less than or equal to 2, if I was to -2 to both sides, we'll have x is going to be less than or equal to 0. That's the first one. Now taking a look at the negative, what happens if we deal with the negative variant? You're going to get negative bracket x plus 2. Of course, this would happen while I record. Of course. So let's take a look here. I don't want 11 standard. Let's see if we're still good. Okay, good. So we're talking about the negative. So if we've got the negative variant, then it's going to be negative x plus 2 is less than or equal to 2. Now, what I want to do is I want to divide or times through by that -1. And so if I do that, hopefully you guys caught that I made a mistake already. I need to flip the sign, right? So now the -2 is on that side. I've got the x plus 2 here. And now I'm -2 to both sides. And there. And those two here, it's less than 0, but greater than -4. I need to be able to recognize that that there is 0, -4. It's going to be the same as before. It's going to be that. Okay, so again, you've got two options here. All right, so last one. If you have a variable in the denominator, this is the one that's strictly extension. All right, so all the other ones may pop up in advanced, but this one is the only one that really pops up in extension. Now, the trick here is, I should write this down. I'm going to write it in red. You want to multiply by the square. By the square of the variable, and I'm going to write slash function. Okay. So the trick here is most people, if I'm thinking of solving this one logically, I'll just multiply both sides by x minus 3. But not the case here because we're going to miss out on a couple of solutions. So the way that we make sure that we don't miss out on some of these solutions is we need to multiply by the square. So if I was to go about solving this, 2x minus 3 greater than 1, I'm going to times by x minus 3 squared on both sides. Okay. So with that in mind, that means one of these is going to cancel out on the bottom, and on the top, it's going to leave me with 2 bracket x minus 3. All right, and on the right-hand side, I haven't multiplied or divided by a negative number, so I don't need to flip the sign. And that's going to leave me with, and I'm going to expand this because I know the expansion, x squared, take away 6x plus 9. Okay, now let's keep going. Let's expand this out a little bit more. So this becomes 2x take away 6 is greater than x squared take away 6x plus 9. Now, if I'm trying to solve something like this, I can see it's a quadratic. There's an x squared, there's an x, and there's a constant. So let's move everything to one side, let it equal 0. So I'm going to have x squared, that's here. And then I've got minus 6x, and I'm going to minus the 2x over. So that's minus 8x. I've got that minus 6, so I'm going to plus it to the other side. And that's going to give me plus 15. I think so. Yeah, that's right. It's going to be greater than 0. Now, again, at this point here, you can either solve it by sketching or you can solve it algebraically. Just because I'm going algebraically, I'm going to finish that off here. So let's take a look at this. I've got, that's going to be x minus 5, x minus 3. And then from here, I just know that, okay, my little note here is that there's something that happens at x equals 5 and x equals 3. I just need to test it. So I've got 5, I got 3, and I'm going to test 0 because 0 is always the easiest to test. So let's take a look and let's substitute it in here. So if I got test 0, so now we'll have 0 to be greater than 0 take away 5, 0 take away 3. So that means 0 is greater than positive 15. Now that is clearly incorrect. That means we do not exist on this outside edge here. That means we don't exist on the other outside edge here. But in fact, we're going to live in between these two then. Okay, so that there is how we would solve an equation like that. And we've sketched it. And that's it. And I probably should write the answer. Hey, so here we know that x should live in between 3 and 5, not including. Okay, hopefully that makes sense. Any questions, please leave them below or ask me in class. I'll catch you guys later. Alrighty, bye-bye.